Everybody okay with this even and odd? Like, we get this, we remember it? You good on? All right. What I want you to think about now, we're not doing this part of the chart today. Okay? But I do want you to do this positive in which quadrants chart. So think about it. I want you to try to fill it in, then talk to your neighbor, see if you agree. Where is sine positive? Where's cosine positive? You have 4 choices.
First and second.
Okay, so this is 1 and 2. Try to fill in the rest of the chart. See if you agree with your neighbor.
The 1 and 2 positive numbers. Like a counterclockwise.
Sorry, guys.
No, not my Fritos.
All right, guys, let's go through them. Okay, guys, up here, cosine, where are you positive? 1 and 4. What about tangent? 1 and 3. Cosecant. 1 and 2 should be just like sine, right? Okay, what about secant? 1 and 4. And cotangent. 1 and 3. Okay? Easy? You're going to have to think about that a lot in this unit. You have to understand the signs. But it all comes down to x's and y's, which you understand where x's and y's are positive, right? Okay. All right. We are skipping the trig identities part for right now. That's going to come into play later when we do trig proofs. It's different than geometry proofs, okay? If you have bad memories of geometry, it's not like that. They're different. Different. So, trig proofs are kind of fun. They're like little puzzles that you have to figure out. Okay, so we are jumping all the way to this part 4 on the next page, okay? All right, so look at these 3 problems. Cosine of 420, cotangent of 17 pi over 4, and secant of 29 pi over 6. Are those values on your unit circle? No, those are more than one time around the circle, right? Okay, so 420 degrees, what is that the same as? 60, that's a coterminal angle, right? Because it's 60 more than 360?
Yes.
Okay, so really this question is asking you, what is the cosine of 60 degrees? And I heard someone say 1/2. See how fast that is? Yes, that's how fast they have to be when we do 20 of them. Okay. All right, so the next one, 17 pi over 4. That is more than 2 pi. What we're going to do when it's in radians is think about turning this improper fraction into a mixed number. You haven't done that forever. What is 17/4 as a mixed number? 4 and 1/4, right? 4 and 1/4 pi. Okay, that's what I'm asking you. Okay, so let's think about it. That's 4 pi and then 1/4 pi. Well, if you go around your circle, 4 pi, what does that do?
Twice.
That's exactly twice around, right? So does that change anything?
No.
No, so really I'm only asking you the 1/4 pi part. Excuse me. What is the cotangent of pi? Because every time around it's 2 pi, yeah. So it's 1, okay? All right, so you guys try number 3. Yeah? Are we okay with that? I wrote that quick. Yeah? Okay.
Are we doing the last one?
Yeah, do number 3 for me.
I got you.
How many times does 6 go into 29?
4.
4, with how many left over? Ah, okay. Think about that. It's secant, so think about it being cosine.
What happens if it ends up being an odd number of pies instead of being a number of pies?
That'd be lining up, like if it was 3 and 5, 6.
Yeah.
So you go 1, 2, 3, and 5, 6. That would be 11 times 6.
That's more annoying.
Yeah, I'll make up one like that for you. All right, guys, what'd you get? Positive or negative? Negative. 2 root 3 over 3. You guys see how those same numbers show up all the time? Because 5 pi over 6 is second quadrant. Okay. All right. I want to make up one more of those for you. That's a little more annoying. Kind of. Let's do sine of. Sorry, I gotta make one that makes sense. No.
I'm not even.
Let's do 22. We'll do 23 pi over 6. Either one would be fine. Okay, think about it though. Because it's not exactly at 5 pi over 6. I realize I made up a very similar one to what I just told you, but that's okay. How many times does 6 go into 23? 3, with how many left over? Okay. 3 pi is not twice around your circle, is it? Ooh, it's over here, right? And then from there I have to go 5, 6 pi. So it's
11/6.
It's like 11 pi over 6.
I got you.
Ooh, okay. So negative 1/2, right? Okay. Are we okay? You want one more of those? That's weird?
Yes.
Okay, let's do cosine. Sorry, I gotta think. I just want to make it work well.
I was thriving in the lawsuit and now I'm just
Are you just surviving instead of thriving now?
not even surviving.
Oh no! Okay. Is this just the end of the quarter talking? Yes, I'm with you. I'm also just surviving right now, barely ahead of water.
Stop it. It's the same.
No, it's not.
Oh.
Okay.
You're right. You.
So guys, how many times does 3 go into 16? 5, with how many left over? So 5 pi, that's Oh, yeah, that's over there, right? Okay. And so from here, you have to go 1/3 pi, or pi over 3, which is right there. And it is negative 1/2 again. Okay? We feel okay with those? Or do we need one more? You want a weird one?
Yes. No. I like.
A weirder one.
A weirder one.
The hardest one you can get.
Okay, let's do...
3.8 trillion pi.
Yes.
Why secant?
You know what?
The 31
It's not that bad.
over 4 is 28, 7.
So you're stop.
Lots of arm action in this unit as you go around and around. It's definitely a unit where you talk to yourself a lot. It's okay.
Have people talked to themselves during quizzes before?
Yeah, sometimes we have to have like discussions of like, okay, like you know what you're doing, you gotta say it quietly, like. How we doing? How many times does 4 go into 31? 7. So this is the secant of 7 and. Okay. So 7 takes me to here, and then 3/4 would be here. I think about the cosine of that first. Cosine of what would that be? 7 times 3. Which is √2 over 2. Positive or negative? Positive. X's are positive over there, right? Okay, so then secant, when I flip it, I just get √2. Yes? Okay? You getting it? Yes, you must remember that secant's related to cosine and cosecant's related to sine. Yeah.
Are we gonna have to learn those in the 20 minutes?
So when we start them, it's just between sine, cosine, tangent stuff. As the year progresses, they will be ones beyond the circle like this.
Oh.
Okay, so they kind of get harder as the year goes because you get better at them, hopefully, in theory. All right, guys. So let's go back up here. Now we have to figure out what quadrant our angle is in. Okay? So let's do this in pieces. I'm telling you sine of theta is less than 0 and cosine of theta is greater than 0. Sine is just my y value, right? So if y is less than 0, where is y negative? 3 and 4. So it could be here or it could be here, right? Okay? Then combined with that, I have to look at the cosine part, which is x. X is greater than 0. Fourth quadrant. Okay? Does that make sense? This is all x's and y's, which you've been plotting those since, I don't know, what grade you guys start plotting points on an xy grid? Yes, fourth, but first?
First grade class.
11th grade. Junior year. I plotted points. Yes. Okay. All right. Try 5 and 6. Once you have them, talk to someone around you. Do you agree? Got a 1 in 4 shot here, guys. So. What? Oh, right.
Look at that. We got the same answer.
Do we know that? Should we maybe make sure this is what? Okay. Kind of a key piece of prior knowledge. All right, let's look at it. Okay, guys, up here. So number 5, cosecant. That's like sine, which means it's your y values are greater than 0. So that's 1 or 2, right? And then cosine is your x is less than 0. So there you go. Yep. Because it could be one of those two. I'm just narrowing it down. I could just put like an x, but this seems happier, so you don't like happiness. Okay. Got it. Noted. All right, the next one. Cosine is less than 0. That's x, right? Where is x less than 0? I'm sticking with happy faces. Okay. Ooh, that's kind of like a 3-eyed happy face. All right, cotangent. This is where it's not really harder, but you got to remember what's happening. Cotangent is both x and y. When you put both the x and the y together, where is it positive?
1 and 1.
Okay, so there's the 2. Okay.
Where is 2 and 4? Both positive. There's that. I think like there's 1. There's 2 and 3. There's 1 and 4.
So yeah, nobody's positive in 2 and 4. I mean, you can remember it like this. I feel like this is one of those memorization things, though, that is like, you could say all students take calculus. Someone else said all students text constantly. That's helpful. All of them are positive. Sine is positive. Tangent's positive. Cosine's positive. Okay. But if you understand what x and y are, you know what I mean? That's you don't know x's and y's. All right, so we okay? That can help. Alpine skiers take cookies? Okay. Yeah, you want to go like in the right order though, right?
Yeah. A reverse stack. Reverse stack.
ACTs if we go the wrong way. Okay. So are we all right with figuring out this quadrant? Let's turn the page then, because we're going to do more of it. That is just too much right now. Not doing that guy right now. Okay, we only have actually a few more examples that we're doing today, guys. So number 7 here, I am telling you what sine of theta is equal to and what cosine of theta is equal to. Based on that information, you have to find tangent, cosecant, secant, and cotangent. So we're going to make a bit. Okay, no, you can't just say no. Oh, do it. It's not an option. All right, we're going to draw a picture. So let's think about what quadrant we're in. Sine is negative, cosine is negative.
Third quadrant.
Third quadrant, okay. X and Y, both negative. Okay. The way you draw your...
Yeah, no, right. It's cosine first.
Because of how it... I mean, you could write it with cosine first. It wouldn't matter. But cosine is definitely X. Yeah. Sine is definitely Y. Okay. The way you draw your triangle matters. Okay? Triangle, yes.
Why are you drawing a triangle?
Because I told you to. All right. Every time you draw it, The right angle must go on the x-axis every time, every time, every time. And the theta that we're talking about is this little angle right by the origin. It's the central angle. Okay? Draw a picture. If you draw the wrong picture, you're going to mess it all up. So don't do that.
Wait, do we have to draw?
Yes. Draw the picture. I clearly am not either, so it's okay. We'll survive together. All right, now go back to what you know about SOHCAHTOA, okay? Because this is clearly not like a unit circle value, right? Like these are weird numbers. So remember, sine is opposite over hypotenuse and cosine is adjacent over hypotenuse. What does it look like the hypotenuse might equal? 5, okay. Just wait a minute. So what is the opposite or the, traveling down distance of my triangle? Good. What's the adjacent or the x part of it? Good. Very good. All right, we okay to that point?
Yes.
So now looking at the picture, tangent of theta. All right, there's theta, opposite over adjacent. You're back to like basic geometry, SOHCAHTOA stuff. You guys know that, right? Like when I'm saying SOHCAHTOA and the sine cosine, like do we know this? Or are you like, it's kind of forgotten? We know it?
Yes.
Okay.
Pretty sure.
Okay. So if I did opposite over adjacent, that'd be negative root 5 over negative 2 root 5, right?
Yes.
What does that equal?
1/2.
1/2. Okay?
Got it? Okay.
Cosecant, that's related to sine, so it's just hypotenuse over opposite. So 5 over negative root 5. When you rationalize that, what do you get? Negative root 5. Good. Secant is like cosine. It's hypotenuse over adjacent. So 5 over negative 2 root 5. Rationalize it. What do we get?
Negative root 5 over 2.
Good. All right, and then cotangent, that's your reciprocal of tangent, so it's adjacent over opposite. What do we get for that? 2.
Okay, why don't we just use the functions at the top instead of dealing with the triangle and drawing it out?
You're going to have the exact same thing. Some of them you will not have as much information, and you need to be in the habit of drawing the triangle.
Okay, because for like the tangent, you just have to take the sine and then you flip the cosine.
Yeah, you can, for cosecant, you can flip sine, which is hypotenuse over opposite, which is this flip, which is this over this, like, it's the same thing.
I know, but like,
Tangent, I didn't even look up here, I just said, oh, tangent's a half, cotangent's 2. Which I've already done the work there, that's fine. But get in the habit of drawing the picture. There are going to be times when you don't have all the information and you need to use the Pythagorean theorem to find other parts of your triangle, okay? And the picture helps you not screw up your signs, okay? Because if I give you, like, if I tell you what tangent of theta is, you got to think about what's actually positive and what's actually negative, what quadrant you're in, okay? I promise the picture helps. All right, so guys, try number 8. Draw your picture for me. I know lunch is coming. Let's see how far we can get.
Oh, we're doing all that.
Do number 8. Ready to go. Alex, ready? Number 8. Ready to go. Okay. Think about the quadrant. Label your triangle. Make sure everybody's drawing their triangle right.
Oh, yeah.
Everybody okay with the picture? Hypotenuse 3, x is -1, y is 2 root 2. Sine is opposite over hypotenuse. So go from your angle opposite over hypotenuse.
Oh.
What? Say that again. I didn't hear what you said. All right, guys, go to lunch. We'll continue. All right, guys, so tangent. What are we going to get for tangent? Good, -2 root 2. All right, cosecant, we'll do it in steps, 3 over 2 root 2, right? So when you rationalize, what do we get? Okay. Good. Okay with that?
Yep.
Yes. All right. Secant, -3. That one's nice and easy. Cotangent. Good. You want me to show you?
Oh, yeah.
Because it would be -1 over 2 root 2. So then when you rationalize, that becomes 4. Yes? Okay.
When we have triangles and we don't have them on a graph, we can't have lengths that are like negative lengths, right?
Yeah, it's just telling you like the direction you're going. But the hypotenuse is never negative. Okay? Never, never, never negative. Got it? Okay. Let's look at 10, 11, and 12. These are the last 3 we're doing, okay? I didn't give you a lot of space here. So number 10. So I've told you what sine is, and then I'm giving you this other. We don't really need the other information about tangent being greater than 0 because I'm only asking you what cosecant is equal to. If you know sine, do you know cosecant?
Yes.
Yeah, so let's just do this one. What's cosecant? Good. That's good that you drew the whole triangle. We're going to draw the whole triangle in the next one, okay? All right, so this one. I know there's not a lot of space, so I'm going to make a little teeny tiny graph here. Cotangent is +4/3, but cosine is negative. What quadrant am I in? Is cosine negative in the first quadrant?
No.
No, so
Second.
no. Third. Cotangent's positive.
Oh,
Okay.
got you.
So my triangle is somewhere over here. All right. Cotangent is adjacent over opposite, right? So I know I've got a 4 and a 3. Are they positive? I know this says +4/3, but negative and negative. Do you see why the picture helps? Okay. -4, -3. What is my hypotenuse? Close. +5. Your hypotenuse is never negative, okay? Always, always, always positive hypotenuse. Pythagorean theorem or Pythagorean triple common right triangles? 3, 4, 5?
Yeah.
5, 12, 13. Do we know that one? Oh, okay. All right, that's another one. Okay, so now that I have it drawn, what is the secant of theta? -5/4, yes. Okay. All right, you guys try 12. Last one of notes. What quadrant did you guys draw in? Two. Secant's related to cosine, right?
Yeah, cosine is the x value.
Yeah, is that negative in the fourth quadrant?
It's positive. But wouldn't negative 2 be 1 over 2?
1 over 2 is not negative, though. Yeah. For cosine, yeah. So we have to be in the second quadrant. Okay. So as we label our triangle here, if secant is negative 2, that means cosine is negative 1/2, right? So what do I know in my triangle? Okay, this is negative 1. What's the hypotenuse? Positive 2, right? What's that other side?
Root 3.
Yes.
Is there a way to solve that other than doing a squared plus b squared equals c squared?
No. Well, I mean, technically this is a 30, 60, 90 triangle, so if you recognize that.
Oh, okay, what is?
How do we know this is a 30, 60, 90?
Well, this leg is half of the hypotenuse. And it has to do that, yeah. All right, so what is cosecant then? 2 root 3 over 3.
That is for today.
Let's see on the notes for today. How do we feel about that? None of it is like super challenging and difficult. It's just a lot of little details you have to talk yourself through. Okay? Make sure you're in the right quadrants. Make sure you've labeled things right. Make sure you know, added and subtracted if you need to with your Pythagorean theorem. Pythagorean theorem, if you need to. So negative 1 squared plus my y squared equals 2 squared. So root 3? Okay. All right, guys.